Hi everybody, welcome back to my YouTube channel. Remember, don't forget to hit the subscribe button. Once we get to 100 subscribers, we're gonna have a, and we're at 61 right now. We're gonna have a giveaway when we get to 100. Giveaway, folks, giveaway, let's go. I just checked the last period. It was 61.
61? I need to subscribe.
So 39 more people, 39 more subscribers, we're gonna have a big giveaway.
What's the giveaway gonna be?
I can't tell you yet. When we get to 85 subscribers, I will announce what the giveaway is. All right. I'll give you this broken candy cane that's been sitting on my desk. All right. So section 7.6 is all about adding and subtracting. You guys will find that the rest of chapter 7, okay, sections 7.6, 7.7, and 7.8 are all operations with these polynomials. We spent a whole day on talking about, okay, what is the terminology that we need to know? You know, what is a monomial, what is a binomial, trinomial, constant, all that stuff. And we talked about how do we name these things, what are the degrees of these things, what are the leading coefficients of these things. You basically know all of the building blocks. You know all of the language now. So now what we're going to do is talk about how we operate with them, how we add, subtract, which is today, how we multiply with them, which is section 7.7 and 7.8. Okay? We don't touch dividing in Algebra 1. You do that in Algebra 2. Okay? So what we're going to talk about today is just adding and subtracting. Guys, let me tell you right now, adding and subtracting is much easier than multiplying. Because in essence, all you do when you're adding and subtracting is just combining like terms. You guys know how to combine like terms? Then you know how to do today. Okay? Just as we can perform operations on numbers, we can perform operations on polynomials. To add or subtract polynomials, we combine like terms. Can you underline that for me? Combine like terms. Combine like terms. That's really all you're doing. You just combine like terms. Remember that combining like terms you can combine terms that are the same variables raised to the same powers. That's what we classify like terms as. Same variables raised to same powers. Okay? All right. You know, I could have given you this problem way back in chapter 1. But now we can talk about it in a little bit more sophisticated way. Aren't these 3 monomials that we are adding together? Right? There are 3 single monomials that we are adding together. Which 2 monomials are we going to put together? The 12 and the 8, right? What can we call those 12 and 8? What are the degrees there? Right, they're both cubic. So we're going to add together the cubic monomials. Don't we sound fancy? Maybe I should put my pinky up when I write these things.
Maybe I'm starting with tiny doors and drinking out of tiny cups.
20p to the third plus 11p squared, right? I mean, that should be super simple, right? Just add the numbers out front. This is the same thing that we were doing before with combining like terms. You're like, Mr. Labrick, give me 1,000,000 of these on the quiz. I can do all of them. And you're like, no, never mind. All right. Oh, I hit. Everybody was here in the attendance, and I think I still have to mark Jamie absent.
Lucky.
I'll get that later. They know she's not here. And Jude too, yeah. Hey, Jamie and Jude, if you're watching out there, hey, how you doing? Yeah. I hope the weather's nice. Hey, it's snowy here, so.
It's about time we'll have snow.
Yeah. And in the car this morning it was 9 degrees.
Yeah, I saw that on my God.
9. You know what I say to that? 9. In German, 9. 9. I know. All right, take a look at B there. Take a look at B. What can I combine? What can I combine? The -6 and the +8. The constants, right? So now, when we write our answers I will always expect you to put them into standard form. Okay? When possible, I always want you to put them into standard form. Can anybody tell me when it's not possible to put something into standard form? Brooke? Very good. Thank you. When you have more than one variable, when you have x's and y's or a's and b's or whatever, when you have more than one variable, it's not really possible to put them into standard form. Some people say that, well, you should go in alphabetical order, then by power. Whatever. I say, don't worry about that. If I put more than one variable, don't worry about standard form. But if I put one variable, it must be in standard form. That means I have to start with the 5x squared. What should come next? What should come next? The minus 3x. And then the plus 2. Right? We were making up the quiz yesterday, and we decided to add into the directions, all answers must be in standard form, because somebody tried to say that, like, oh, you didn't tell me to put it in standard form. You didn't tell us, so you can't take points off for that. What can I do with this? Can I put them all together? Different variables now, right? Can I possibly put this one into standard form? No, I've got two different variables. So I'm just going to go, I'll put the t's first then. So what do I get when I combine those? Gavin, what do I get?
You get
T squared and negative 4t squared.
negative 3 t squared.
Very good. And then we've got the 2 and that. So what do we get when I put those together? Noah? Okay. Plus 1s squared or just plus s squared? Yeah, some people say it's a little bit more proper to say they put the s before the t because, alphabetical order, but whatever. What can I do with all of these? Yeah, these are all like terms, aren't they? These are all m squared n. So I've got 10, 4, and negative 8. What do I get?
M squared n.
Good. 6m squared n. Does that make sense? Okay, let's keep it going then. All right. So those were just adding monomials. Okay. So when I do this, guys, the notation makes it look like, what am I doing? I'm adding a binomial and a trinomial, right? But when I'm adding, those parentheses don't really matter. Okay? When I am adding, the parentheses don't really matter because addition is commutative. And I can change the order or change the grouping, and it's also associative. I can change the order and I can change the grouping, and it's not going to change the outcome. So you know what I can do? I can really just ignore those parentheses. And now this becomes a problem that I just did on the last slide, right? So now what we're going to do is just combine the like terms. I'm going to say, okay, 4m squared and an m squared gets us a 5m squared. What should come next? Minus m. Good. In standard form. And then a 5 and a 6 make 11. Does that make sense? So just make sure that you're putting it into standard form always. So when you're adding, you're basically just combining like terms. You're just ignoring the parentheses and just combining the like variables. Can I possibly put this one into standard form? No. I've got two different variables. So it doesn't matter the order. 10xy and a negative 3xy. What do I get? 7xy. Okay, I've got an x that doesn't combine with anything and a y that doesn't combine with anything. Would the answer x plus 7xy plus y be acceptable? Of course. You can change the order. I can't take off points if you change the order because this cannot be put into standard form. I'm just trying to make this as difficult as it could possibly get. And this is not that bad at all, right? I'm combining a binomial with a 4-term polynomial, right? Okay, well, again, if it's just addition, just put together the like terms. I'll go with my x squareds first because I see some y's, so I don't need to worry about standard form. X squared and 3x squared, or sorry, 6x squared and 3x squared make 9x squared. Those go away. I would encourage you to cross out every time that you bring down a set of terms, cross out the ones that you used, just so that they're all there. Oh, I forgot a minus 8x squared. See, if I would have correctly crossed them out, I would have seen that, oh, I had another x squared. And then I've got, the rest of them are just y's, aren't they? I've got a negative 4y, a 3y, and a negative 2y. So what do I get when I combine all those? I get a negative 4 plus 3, which is negative 1, and then minus 2 more is a negative 3y. Can anybody name that for me? What would the final result be named as? What would the final result be named as? Emily? Quadratic what? Quadratic binomial. Good. Quadratic because the degree is 2. Binomial because there's 2 terms. Who was playing Kahoot? I heard a Kahoot music going on. Okay, so we talked about adding. Now let's talk about subtracting. But flip it over onto the other side. Oh, Piper, don't start complaining. I called you out. I called you out on the YouTube.
Yeah. What do you need to know?
So to subtract, it's really not very difficult. All you need to do is that remember that subtracting is adding the opposite. So when I go to subtract, you're just adding, you're just combining the opposite of that term. Here's what I mean. If I have some polynomial and then I've got minus this trinomial, all you're going to do with that subtraction sign is just distribute it into the polynomial. You're just going to take the opposites of all of those terms. So it's going to turn into a minus 2x cubed, it's going to turn into a plus 3x, and it's going to turn into a minus 7. All you're going to do is just distribute with that negative sign. And then combine like terms. It's literally only got one additional step on it from the addition process. So let's try that. Okay, well, if I bring the minus sign in, all I'm going to do is just bring it into there. So this turns into x to the third plus 4y minus 2x cubed. Guys, I would always like you to write that second step in. I know there are going to be some of you that are like, I don't need to do that. I understand this stuff. Guys, please just write the second step. Make sure that it's there. So this is a minus 1x cubed plus 4y. Right? Or a negative x cubed plus 4y. Does that make sense? Okay. So again, I distribute in the negative, right? I distribute in the negative. And what do we get? Well, the first term stays exactly the same. The first polynomial, 7m to the fourth minus 2m squared. That binomial does not change. What changes is the second set, the second polynomial, minus 5m to the fourth plus 5m squared minus 8. Does everybody see what I did? Everybody's sign changed. And now we just combine like terms. We've got a 7m to the fourth minus 5m to the fourth to make a 2m to the fourth. We got a negative 2m squared plus 5m squared to get a positive 3m squared, and then the plus 8 sitting out on the end. Can anybody name that for me? What would the name of that one be? Dylan?
Yeah.
Oh, thank you, Dylan. Oh, boy. I screwed up. I'm done messed up. I'm done goofed. Dylan, name this for me. Thank you for raising your hand when I asked. Who can name this for me, even though you're just pointing out my mistake?
I don't know how to name it.
Oh, come on now. What's my degree of this? Pull out your guided notes there. Did you fill in the table?
Yeah,
You sure?
I don't know what my dad names are. I just
What?
had
Dylan Snyder.
I just had it out. It's like
Look at that disapproving look Maddie's giving you right now. She just was shaking her head. Can somebody help him out? Somebody help Maddie, thank you. A quartic trinomial, good. What's my degree here?
4.
4. 4. What do you think about 4 quarters, right? Quartic. Quartic, how many terms? 3. Trinomial, second tricycle.
Yeah, you said that Quince thing yesterday. No,
That's 5.
no, Quince is 15.
I know, but it's not the degree of 15.
I know it's not
No better.
15, but like, I know, but I just think about that every time someone says Quartic.
15. Okay, bring in the minus sign here. We get negative 10x squared minus 3x plus 7 minus x squared plus 9. Whoa. Negative 10 and negative x make negative 11. Oh, nothing to combine with them, minus 3x. I should be crossing out as I go. 7 and 9 make 16. So subtraction's not that bad either, right? Addition and subtraction should just be combining like terms. That's really all it should be. It's nothing more than that. I'll give you guys a head start. You're welcome. Questions on that one? Take a look, make sure that your answer is the same as my answer. We all right there? Questions? So what did we learn today? We learned how to add and subtract polynomials, right? We added and subtracted monomials together, then added and subtracted polynomials together. That's really it for the quiz on Friday. All the quiz on Friday is going to be identifying degrees and identifying leading coefficients and putting things in standard form, some naming. You need to memorize the names of those things, people. Yeah, make flashcards, do whatever you need to do. And then just some addition and subtraction. Easy peasy. All right, everybody say bye.
Bye, YouTube. Adios.
Adios. So long. Farewell.